Leetcode problem 707, design linked list. Yeah, so this is the very basic of design patterns of linked list. I think it's gonna be a lot of code, and it's really easy to make mistakes. So we have to be clear with the requirement of the question. So we have a class, so linked list, and we also have the get. So get is get the value of the index node in the linked list if the index is valid. Otherwise, we're gonna return a -1. And also for this add at head and add at tail. So add a node of value of val before the first element of the linked list. So let me just make a drawing. So normally for a linked list, we're gonna have a dummy node. So for this dummy node, we're gonna define it as head, as self.head. So this is gonna be the head, and then we're gonna have the next node, maybe it is 1, and another node, next node, maybe 2. After 2, it may be now. So this is gonna be a singly linked list. So in this problem, I'm gonna design a singly linked list. So at the head, we're gonna put some node. So after this head, so for example, there's a node 0, we're gonna put it after the head and let it connected to 1. So this is for so this is for add at head, and add at tail is after 2, we're gonna prepare a node maybe 3, and after 3 it's gonna be none. So this will be add at tail. So append a node of value val as the last element of the linked list. And there's also a function add at index. Because it is a 0 indexed, so for the index here, this position it is a 0, and for this node 2, it is 1. So we should be clear about that. Yeah, so let me just clean a little bit. So this is index 0, and this is index 1. And we also have a delete at index, delete the index node in the linked list if the index is valid. So if it's not valid, we will not do anything. Yeah, so if we understand the problem, normally we can start coding. So let's just have a check of the example. So we have my linked list and add at hand. So let's try to check it. So from beginning it is empty, now at head 1, and at tail 3 it's gonna be 1, 3, and at index 2 is the last index, it's gonna be 2 gonna be index 1, at index 1 it's gonna be 1, 2, 3. It's not the last index, it is index 1. Yeah. So we're gonna get 1, at index 1 we're gonna get a 2. So this is the index 0, 1, and 2. And delete at index 1, delete 2, and it's gonna be 1, 2, 3, and get 1. So we're gonna return a value at index 1, so it's gonna be 3. Yeah, so if we understand it like that, basically we can design the linked list. So I'm gonna keep the same class name as the Python linked list. So I'm gonna use the linked list. No linked list. I'm gonna design a list node. It's gonna be the same pattern of a list node, and I'm gonna initialize it. So inside I'm gonna give a self, and this value I'm gonna set it as 0 by default. Now the self.val should be equal to val, and the self.next should be equal to unknown. Yeah, so it's gonna be exactly the same. Now we're gonna prepare the initialized function, because we need to have the size of the linked list. Yeah, because basically we're gonna use this index to check the size if it is out of the range. So we're gonna return a -1. So for this get function, so this means we're gonna need a self.head should equal to list node. So it's gonna be anything that is okay, because this head is just a dummy node, and we also need a size because we need to record the size. Yeah. So basically, we prepared everything for the linked list. So this is a head and node 1 and node 2. Yeah, let me just clean a little bit about these areas. Yeah, so this is a node 1, 2, and this is index 0, and this is index 1. Yeah, now let's get back to this get function. So we're gonna check the index. If this index is less than 0, or this index is more than and equal to the self.size, it means it is impossible, so we're going to return a -1. Now we can get now we can get where it is. Now we can get to the index. So for example, if we want to get index 0, we want to get this value, it should be 1. But how can we do that? Yeah, so from the beginning, we're going to prepare a dummy node. Maybe we're going to prepare a node P. So P should be equal to this self.head. So P going to be starting from here. Yeah, if we want to get the first value, yeah, so normally it should be index plus 1, because if index plus 1, 0 plus 1, it is 1. We're going to go to the first node and we're going to get the value. So we're going to use for I in range this index plus 1, and in this way we can get the value. So P should equal to P dot next, and we can just get the value. So we're going to return P dot val. Yeah, so this would be the get function. Let's just have a check. So currently P is here, so index is 0. If we were to check the value of 0, so for I in range 0 plus 1, it is 1. So P should equal to P dot next. P would be here, and then we're gonna stop, and we got the value. So P dot val should be 1 for this example. Yeah, I think basically this is okay. So we need to define the P should equal to self.head. Yeah, so this would be the get function. Now we are going to check the add at head and add at tail, because we have this function add at index, so we're going to use it. Yeah, so we're going to return it directly, self.add at index. So if it is a head, we're going to add it at index 0 and going to have a value. So if it is at tail, it's going to be the last one. So in this example, if it is a head, so from here we're going to add it. After the head, we're going to add a node, and let's connect it to the index 0, to the first node. If it is a tail, it's going to be here. So the position would be the after the last node. So it's going to be we're going to use the self.size. So this is a size. This is 0, 1, and it should be at position 2. 2 is the number of the node. It's going to be self.size. So we're going to use the position of self.size. So this means 1, 2, and then add another one. So we're going to use the self.size with the value. Now let's go to the add at index. So this is going to be a little bit harder than the other functions, because basically we need to take care of all those head and tail and also in between. So we have to check the index first. So if index less than 0 or index so here should be more than, yeah, so if yeah, so this is okay if this index is more than self.size. Yeah, because basically this index can equal to self.size, as you can see at tail, add at tail, we're going to use this self.size. So if this index is more than that, it means it is impossible. So let's just have a check. So yeah, self.add at index, if index equal to the length of the linked list, the node will be appended to the end. If the index is greater than the length, so if the index is greater than the length, so the node will be node will not be inserted. So we're gonna just have a return. Now we're gonna insert it. So before insert, the self.size should plus equal to 1. Now we're gonna insert it. So for example, if we were to, so this is the head. If we were to insert maybe at index 0, so what it would be like. Yeah. So if we were to insert at 0, so we're gonna use a for loop. So for I in range index, I think it's enough because we don't need to change the p pointer. The p pointer should be fixed at the head because we are insert at index 0. So we can just use a for loop for I in range index. So and then we're gonna prepare a temp. So maybe this node is 3. This node called T node maybe. Yeah. So this T node would be this node 3. So we're gonna let this T node ported to this head.next, and this head will connect it to this P node. So basically we will do such kind of connections, and it should be okay. Now we're gonna connect it. So P should be equal to self.head. So for I in range, here we're just gonna use this index because as I explained, this index is okay. If we were to insert at 0 position, we don't need to use the for loop. Now P should equal to P.next. If it go out of the for loop, so we're gonna prepare a T node. So this T node is like a temp node. So let's name it temp. It would be this node with this value, and temp.next should be equal to P.next, and P.next should equal to a temp. So it would be like this if you see it from here. So this is our temp. Yeah. So temp.next should be equal to P.next. So temp this node.next, so the P.next it is here. So 3 would be connected to 1, and then P.next. So this is P.next should equal to this temp, and this is a temp. Yeah. So this means the connection is okay. Now we just need to check the last one, delete at index. Yeah, so delete the index node in the linked list if the index is valid. So if it is invalid, we will not do anything. So let's just copy the same code from here. So the index, if we want to delete, so for example, this is index 0, this is index 1, but there's no index 2. It means it's going to be size minus 1. Yeah. So if this index less than 0 or this index more than or equal to the size, we cannot delete it. So we just have a return, and then we're going to use the self.size minus 1, and then P pointed to the head. Yeah. Now I think we can delete these areas because normally deletion is much easier than the insertion. Let's just check delete. So for example, we want to delete some node. Yeah, let me clean a little bit about these areas. Maybe we want to delete a node of index 0. So this is the index 0. We want to delete this node. So this is a P. How can we delete it? Yeah. So if we want to delete this node, we're going to use for I in range index. So index is 0. We didn't do anything. Yeah. And then P.next should equal to P.next.next. So we're going to just jump through this one. We're going to delete this one. Yeah. So it means from here, and P.next should be equal to P.next.next. So this is the deletion. It's going to be much easier. Yeah. Now let me just have a check if everything is okay. So for here, I prepared a val equal to 0 by default inside the init. So this means I don't need to put a value inside if it is a dummy node. So this head is just a dummy node. Why we use a dummy node? That is just the design patterns of a linked list. It's going to be easier for the calculation to the get, at head, tail, or the index. It's going to be much easier if we use a dummy node such as self.head. After using the head, we can use this p pointer pointed to this dummy node and just to start all the other operations like the get and add at index and delete at index. So for add at index, we can use this self.size. So this is why it is the index more than self.size. Yeah, but for deletion, we cannot delete the index at self.size because the index gonna always be self.size minus 1. And the deletion, we deleted self.size minus 1, and also for the add, we plus 1. Yeah, let me check others. Yeah, it seems it is okay, but I'm not sure. Let me just run it to have a check. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases, and the time complexity, I think, so we are having a linked list. Why we are using a get, as you can see, it is on. It's dependent on the index because it is a singularly linked list. While we add at hand, this is O1, add at tail, O1, add at index, this is also On. It is dependent on the index, and the deletion also is On. So this is why linked list, the so the insertion, so for a linked list, we can see that if we were to get an element, if it is an array, we can just use the index. But for a linked list, we're gonna use on time. Yeah, if we were to delete something, it's gonna be on time. If we were to add at some index, it's gonna also be on time. Yeah, only if we add at head and add at the tail, that's gonna be just. Yeah, if we add at the head, it is just O1 time. But if we add at the tail, it's still gonna be on time. So this is why the difference. Yeah, although the space is just O1, but the time, most of the operations will become On. Thank you for watching. See you next time.